Hope you missed me. I'm back. Next video, guys, we're going to talk about rate of change and slope. Okay, these are two familiar concepts to you. Again, we're just going to delve a little bit deeper into them. All right, so let's go to vocab first. First thing you're going to want to know about is slope itself. Okay, which is always rise over run. Okay, now again, you talk about on a little graph. Okay, it's however much your line goes up. Okay, so like here's our, let's see if this is our line and we had 2 points. It would be rise over run, just like that. Rate of change is going to be the same kind of thing, except it will be, I want to say, vertical change. Vertical change. Over horizontal change. Trying to go fast and it's not working. Okay, vertical change over horizontal change, and then slope-intercept form. Your best friend in math, well, at least with graphing, is y equals mx plus b. Okay, and you guys know, again, we'll break it down here in a second, so you guys just need to make sure you guys know that stuff. All right, and I spelled vocabulary right, so you're welcome. All right, here we go. Next one. Again, here's your formal definition of rate of change. Again, it's a ratio that compares how much one quantity changes, on average, relative to the change in another quantity. Now, again, we're always going to be using it as the change in y. Again, I'm just going to write it again so you guys can get the idea. So I'm going to say change in y, and again, we know that y has a bunch of different values. Y can be it can be the range. It can be the dependent variable. Okay, there's all these options that y can be. Okay, so it's going to be, these are just options here. All over, okay, with respect to the change in x. Somebody's having a good time. All right, change in x, which is also to be known as, it could be the domain or the independent variable. Or independent. I'm trying to write really small and it's not working, so I apologize. Hopefully you guys can see that. Independent. Okay. Moving on. Slope itself, okay, is going to be probably the most important concept with lines, just because slope it never changes. It's always the same for any given line. So again, like I said, it's the ratio of the change in the y over the change in the x. Okay, so again, the way that looks, again, you heard me define it earlier as rise over run. So what you're going to do is okay, so you're going to take the second y coordinate minus the first over the second x coordinate minus the first x coordinate rather. Okay, so again, make sure you're being careful with that, guys. Again, it's always going to be y's on top. You'll always hear me refer to this as as yum over picnic table. Just a stupid way for me to remember that the y's are always on top. All right, moving on. Here's our first example. Now, again, this is not a graphic example, but it's okay because we can figure it out the same way. So in 2004, it says 56,878 students applied to UCLA. In 2006, 60,291 students applied. Find the rate of change in the number of students applying for admission from 2004 to 2006. Okay, so the way to think about this is when you're thinking about a graph, just like nice simple graph, something like that. Okay, the independent variable, okay, or the independent variable always goes on the x-axis. Okay, so in this case, time right here is always going to be independent. Okay, because again, we can't affect time. Time's going to go on happening regardless. All right, so from this case, like 2000 and these years would go on the bottom. It'd be like 04 right here, 04, and then 06. All right, and then again, the students can go on this one, or on the y-axis. Okay, the students will be, or let's say number of students applied. Okay, on the y-axis, and here's y, here's x. So now, again, it doesn't really matter where I start here. Again, if I just, I know that these values are my y values. So again, I'm just going to have this one be, again, so here's my x. This is going to be x1. This is going to be, oh gosh, guys, long day today. Here we go. Subscript, okay, on the bottom. So x1, this will be y1. This here will be x2. This will be y2. And we're just going to plug it into the formula, okay, the one that was on the last slide. So m equals y2 minus y1 over x2 minus x1. All right, so let's do it. So we've got 60,000. So our slope here, or m, is going to be 6,291 minus 56,878 all over 2006 minus 2004. All right, so again, I will get out my handy dandy calculator because I don't know what that is off the top of my head. Okay, let's see what we got. So 60,291 minus 56,878 equals. All right, so on top we'll have 3,418, I believe is what it was. 13. Whoops. And then on bottom we're going to have 2. And then the last step we can just divide it out. So it would be 3,413 divided by 2. So our slope, or our m, will be 1,706.5. So 1,706.5. And it says that it's a rate of change. So let's say students per year. All right, let's go to the next one. All right, now these guys, these are simpler, okay? Again, you're just going to see these kind of be just the standard kind of problems as we go through. So again, I like to label mine, so I'm going to go ahead and do that. This one will be x1, y1, x2, y2. All right, and then you'll do, so start with y2. So it'll be m will equal negative 2 minus 4 over 1 minus negative 1. Be careful here, guys, again, because that is where most people mess up with these minus negatives. All right, so on top, negative 2 minus 4 is negative 6. And then here, minus a negative becomes plus a positive. 1 plus 1 is 2. So your final answer for the slope will be negative 3. All right, so we'll do same next one here. Again, same deal. So x1, y1, x2, y2. Again, if you guys want to try these on your own, I encourage you to pause them, try them, and then you guys can come back and check it out. Be careful. These C and D are going to be a little bit weird though, so we're going to do those together. So just be careful with them. All right, so now this one, keep going. So y2 is negative 4, minus y1 is 3, all over x2 is negative 4, minus 10. So negative 4 minus 3 is negative 7, all over negative 14. Negative over negative becomes a positive, and then 7 over 14 reduces by 7. So it'll be 1/2. All right, now again, these are your 2 special cases, so I'm going to go through each one individually. So again, you label them. Again, I know it seems tedious, guys, but it helps every time, I promise. All right, so we'll start it. We'll do 3 minus 7, and this is m. 3 minus 7 over 5 minus 5. So this will be 3 minus 7 is negative 4 over 5 minus 5 is 0. So first special case, all right, whenever you have 0 on the bottom, you guys might know this already, okay, if you put it in your calculator, it'll give you an error. I can even show you that, okay. If I did 4 divided by 0, okay, cannot divide by 0. Boom, look at that. My calculator is doing my work for me. Okay, you cannot divide by 0. Okay, it is something that is called undefined. All right, undefined. Okay, now again, if you are graphing these 2 points, the line would look like this. 5, 7 would be up here. 5, 3 would be right here. Okay, it's going to be straight up and down, just like that. So this is an example of an undefined line, or a line that has an undefined slope. All right, last one. Again, label them. So x1, y1, x2, y2. So in this case, it'll be m will equal 1 minus 1 over 8 minus 2. Make sure whatever parentheses you start from, just make sure to start from that same one on the bottom. So this will be 0 over 6. Now again, we can try it again with our calculator. If you do 0, whoops, so clear it. 0 divided by 6 is 0. Okay, now again, you shouldn't have to use your calculator for that, but again, I just did it just for show. So again, the slope here should be 0, and there you go. All right, let's keep going. Now this one's a little bit different. What you're going to do when it gives you a graph to use, what I want you to do is I want you to actually, I want you to like just kind of find out points that work. So I see that, when I say points that work, I mean points that hit cleanly. So I see a couple points that hit cleanly. The first one is right here, okay, at 2, or at 0, comma 2 rather. And the other one I see -1, -1 maybe right there. I think that looks good. That one looks good to me. Or this one right here would work too. -2, -4. And we're just going to do the rise over run. Okay, so again, you're going to count how many units you go up, and then that'll be on top. And then however many units you go over, and that'll be on bottom. Rise over run. So m will equal, it's going to be a fraction, so let's count it. So we're going to go up 1, 2, 3 units, so 3 on top, and then over 1, 2. So 3 over 2 is my slope. And again, you can count from down here if you want. You can go up 1, 2, 3 and over 2. You can even count up 1, 2, 3, 4, 5, 6 and over 1, 2, 3, 4. 6 over 4, which reduces by 2 to 3/2. All right. Next thing, slope-intercept form. Okay, again, I told you it was y equals mx plus b. M is always the slope, b is always the y-intercept. Okay, so like in this case, the y-intercept was 0, 2. So we would put a 2 right here for our b. I want you to go ahead and write this down, and I want to jump right into the examples because I'm kind of running short on time here. All right, so again, when it says find the slope of the line, what it's really asking you to do is solve for y. Okay, and by that I mean put it in y equals mx plus b form. So let's do it. So again, here's my y, I got to get by itself. Subtract 4x from both sides. Again, I can't combine those, they're not like terms, so it'll be 3y equals -4x plus 8. And last step is to divide by 3. So it'll be y equals -4/3 x plus 8/3. Whoop, there goes the light. Okay, so the slope is right here, -4/3. Next one, again, you're going to do the exact same thing. It will be, again, you're solving for y. So make sure you leave the sign here in front. So I'm going to subtract 12x from both sides. So it'll be -4y equals -12x plus 7, because it's a positive 7 here. And then divide by -4. So it will be y equals positive 3x minus 7 over 4. So the slope is 3 here. All right, one more that I want to do is right here. Okay, it says the line contains the points 6, r and 10, 8 and has a slope of 4. So this is going to be a little bit different, but it's just the same thing. We're just going to use the slope formula again. So y2 minus y1 over x2 minus x1, and I want you guys to label your points. So x1, y1, x2, y2. All right, and then the slope is 4 again. So we know that the m then is going to be equal to 4. So 4 equals 8 minus r over 10 minus 6. Work out the bottom first. 10 minus 6 is 4, so 4 equals 8 minus r over 4. To get rid of the fraction, multiply. These cancel here. 4 times 4 is 16, equals 8 minus r. Subtract 8. 8 equals -r. Last step, divide by -1. r equals 8. So it would be 6, 8 to make this a true statement. Guys, I'm all done. All right, see you later.